Union and intersection of events. A Venn diagram can be used to illustrate the relationship between events and the corresponding sample space. We may take the rectangle as the sample space and the circles to represent events. So again, when we talk about Venn diagram, it is a diagram that shows all the possible logical relations between a finite collection of different sets. Example number 1. If we have a dye experiment, the sample space will be 1, 2, 3, 4, 5, 6. So we have the number of elements in the sample space is 6. Let's say our A represents the event that the number is even. And then our B represents the event that the number is a multiple of 3. And our C represents the event that the number is a multiple of 5. So using the Venn diagram, we illustrated the following events. Again, in our event A, we have our even numbers. So we have 2, 4, 6. And then for event B, we have numbers multiple of 3. We have 3 and 6. Then for event C, we have a number which is a multiple of 5. Other than this number, we have 1 which is not found either in our A, B, or C. But this is still part of the given sample space. So from here, our event A is equal to 2, 4, 6 or the even numbers. Our event B is equal to 3, 6 or our numbers multiple of 3. And event C, we have 5 which is a number that is multiple of 5. Universal set, which is denoted by capital letter U, is a set consisting of elements in the totality of all sets under considerations. So this is simply means the sample space. We have 1, 2, 3, 4, 5, and 6. Those are the outcomes in a dye experiment. So again, we have the universal set which is equal to 1, 2, 3, 4, 5, 6. We have also what we call complement of event A, which is denoted by A prime, or this is read as A complement, is the set of elements that are not in event A, but it is in the universal set. So if we're going to have this given figure or the Venn diagram, if we're going to take the A complement, so here is our event A, we'll find all the elements that are not found in the event A, but still part of the universal set. So this is an illustration of our complement of the event A. So from here, we can say that A complement is equal to 1, 3, and 5. Intersection of the two events A and B is a set of elements common to both events A and B, and this is denoted by this symbol and read as A intersection B. Using the Venn diagram, the shaded region is A intersection B. So we'll just have to look between the events A and B, what is common between them. So from here, we can say that A intersection B is equal to 6. Union of the two events A or B is a set of elements that are found in event A or event B or both A and B. And it is denoted by this symbol and read as A union B. Using the Venn diagram, the shaded region will describe or illustrate A union B. It just means that all the elements that we can find from event A, event B, or both events, or we'll just have to combine all the elements, that refers to the union of the two events A or B. So from here, we can say that A union B is equal to 2, 3, 4, 6. Example number 2. There are 10 chips numbered from 1 to 10 in a bag. A chip is drawn at random from the bag. Let A be the event that the number is odd number, and B be the event that a number is a prime number. Then let us find the following. A intersection B, A union B, A complement union B complement. So again, we have the universal set or the sample space from the 10 chips found in a bag. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for event A, we have odd numbers. So from this given sample space, the odd numbers are those numbers that are not divisible by 2, such as 1, 3, 5, 7, 9. And then for event B, we have prime numbers. Prime numbers are those numbers having factors 1 and the number itself, such as 1, 2, 3, 5, and 7. So if we're going to illustrate our given example using the Venn diagram, again, our event A is the event that the number is an odd number, such as 1, 3, 5, 7, 9. Event B is the event that the number is a prime number, such as 1, 2, 3, 5, 7. Other numbers or elements in the sample space that can still be found in the universal set, such as 4, 6, 8, and 10. So let's have first A intersection B. If we're going to look at our Venn diagram, this region illustrates the intersection between event A and B. So we have 1, 3, 5, 7. Or if we're going to refer to the two given events, we'll have to look for what is common between A and B. So we have 1, 3, 5, and 7. We don't have 9 here, and we don't have 2 here. So the A intersection B is equal to 1, 3, 5, 7. Next is A union B. So in A union B, we'll have to look for the elements that we can find in the event A or event B or both event A and B. Or meaning, we'll have to combine all the elements. So from here, we can have 1, 2, 3, 5, 7, and 9. Or from the given set, we have event A and event B. we'll just combine all the elements. So we have 1, 2, 3, 5, 7, 9. So again, the A union B is equal to 1, 2, 3, 5, 7, 9. And then we have A complement union B complement. So we'll have first the A complement, all the elements that we can find in our universal set, but not in event A. So in our event A, we have odd numbers such as 1, 3, 5, 7, 9. So in our given sample space or the universal set, we'll have to take the remaining elements, or those are particularly the even numbers. So we have 2, 4, 6, 8, 10. And then we have the union and the B complement, all the elements that are found in event that are not found in event B, but we can find in our universal set. So again, in event B, we have 1, 2, 3, 5, 7, which are prime numbers. So in our sample space, we can take the remaining elements that are not prime numbers, but are basically known as composite numbers. So we have 4, 6, 8, 9, 10. Our composite numbers are those numbers having factors more than 2. So aside from 1 and the number itself, there are other factors. So again, we have 4, 6, 8, 9, 10. Now, getting the union between these two events, we'll just have to combine all the elements. So we have 2, 4, 6, 8, 9, 10. Example number 3. The Venn diagram below shows the number of elements in set A and B. If the number of elements in A union B is 25, the number of elements in A intersection B is 7, and the number of elements in B is 10, let us find the value of X and Y. So we have our given Venn diagram. For the event A, we have X plus 7, and for event B, we have 7 plus Y, and if you have seen, the intersection will be 7. So first, our number of elements in event B is equal to 10. And then we have again the elements of the events B. We have the number of elements 7 plus Y. We substitute the value of that, which is 10 here. So we'll have 10 is equal to 7 plus Y. We already formed a linear equation. Using APE, we'll add negative 7. So we'll have Y is equal to 10 minus 7, and that is equal to positive 3. And then we have the number of elements of A union B as given will be equal to X plus 7 plus Y. Since we're going to combine this, you will have X plus 7 plus Y. And by substitution, the number of elements of A union B is 25. We'll have 25 is equal to X plus 7 plus Y. And we have solved a while ago that Y is equal to 3. So we substitute the value of Y, that is 3. So we have 25 is equal to X plus 7 plus 3. 7 plus 3 now is equal to 10. We have formed again a linear equation, so we apply APE. We'll add negative 10 both sides, so we'll have X is equal to 25 minus 10, and our X now is equal to 15. So the values of X and Y are 15 and 3 respectively.